In this video, I'll be presenting our work on task-directed exploration in continuous POMDPs for robotic manipulation of articulated objects. A POMDP is primarily defined by a stochastic transition function, from which next states and observations can be sampled given previous states and actions. The objective of a POMDP is to maximize discounted reward over a trajectory. However, directly maximizing this using standard methods can fail to experiment with information gathering actions in long horizon tasks. To account for this, some methods regularize the reward with an additional term that encourages gathering information. Another way to do this is by active learning, where the problem is split up into separate information gathering and goal-seeking parts. The primary issue with these strategies is that there is often significant uncertainty that is not relevant to the goal. In this work, we regularize the reward with only the uncertainty relevant to the task. Here you can see a toy domain in which the agent is uncertain of its initial position, and it has to reach the green goal region. It can reduce uncertainty in its x position by approaching the right wall, and it can reduce uncertainty in its y position by approaching the top wall. Under standard reward maximization, the information gathering actions are never found because the task is too long horizon. If we instead regularize by the uncertainty magnitude, we see that the agent approaches both the top and side walls. If we only regularize by task-relevant uncertainty, we see the agent only reduce uncertainty in the x dimension by approaching the right wall. We also experimented with several robotics tasks where there is uncertainty over kinematic joint types and parameters. The agent can reduce uncertainty by partially executing a controller and observing the effect. Here we see a plan found by our algorithm that only reduces uncertainty in one of the drawers. This strategy works similarly for cabinets with doors. Here we see a task where the goal is to place an object on top of the shelf. Notice how our method doesn't interact with the cabinet door at all, even though it's uncertain about the joint parameters. Here's an example of over-exploration, something that was particularly common when reducing general uncertainty instead of task-relevant uncertainty. Here's an example of full controller execution under incorrect joint assumptions. These plans were typical of methods that don't add any uncertainty regularization. Thanks for listening. Please see our paper for more details.